This is an AIPMT 2016 question. Problem is like this. A tube of length L is filled completely with an incompressible liquid of mass M and is closed at both ends. Let me draw the diagram of that part first. That is a tube. This is the tube. It is closed at both ends, whose length is L, filled with a liquid of mass M. Tube is rotated in a horizontal plane here. The tube is rotated in a horizontal plane about one end, with its other end having angular velocity uniform omega. Then the force exerted. That what he is saying further is this end of the tube is fixed. This is entire tube is rotated around this about this axis. What is the force experienced by it? Let us consider a small portion of the string whose mass is dm. Let the length of that small portion is small dx. So we can say mass of that small element is total mass by total length multiplied by the length of that part, m by l into dx. This small part, let's assume, is at a distance x from the axis of rotation. Then being in rotational motion, this small element experience a centripetal force dF equal to dm x omega square. Because the mass we are considering is small, respective force also will be small. How much is that? dm means we have already calculated. Total mass by total length into dx and x omega square. That is small force. Like that, there are so many elements throughout the tube. For each of that, we have to calculate the force and add all of them. That's called integration. To get total force, we shall integrate the equation. Integral of df is integral of m by l dx x omega square, where x could be anywhere. Because this element could be starting from here and end could be here, right? So it could be 0 to L. So integral of differentiation of f is f, m by l is constant, omega is also constant. It was given that it is having a uniform constant angular velocity. So what's remaining is integral of x dx 0 to L. Yeah, let us simplify this. Using a formula, integral of x power n dx is x power n plus 1 by n plus 1. Integral of x power 1 dx is x power 1 plus 1 by 1 plus 1. That is x square by 2. So this part becomes x square by 2. Yeah, that implies force F equal to m by L omega square. Integral of x dx is x square by 2, whose limits are varying from 0 to L. So m by L omega square by 2 also can be taken outside. X square, for that first I have to apply upper limit and then minus lower limit as per the rule of integration. So what's your answer is m by L omega square by 2 L square. 1 L can be cancelled. So the total force acting on the liquid is half ml omega square. That is the answer. Yeah, this one. Option A is the answer for the problem. So to solve this problem, we have used some basic concepts. I will quickly remind you that what we have used. First thing we have done is, as we have to calculate the force, we have considered a small element whose mass is dm, whose size is dx, who is at a distance x from the axis of rotation. For on that small, I have calculated the mass of small element. Then I have written an equation for the centripetal force. substituted that value, and as that's only a part of the force acting on small element, to get the total force, we shall find force on each of the element and add all of them. Doing like that is called integration. In integration, I have used only one simple known formula that we use quite regularly. Integral of x power n dx is x power n plus 1 by n plus 1. By simplifying, I got this answer, right? That's how you have to understand and solve the problem. Thank you for watching.